Hey everybody, welcome back. It's Ripley here. We're going to go over the rest of the information from Chapter 2 today, and that has to do with graphs of data. So now, not only have we organized the data using our frequency distribution, if we look back here real quick, let's look at the pretty one. That's a pretty one right here. This is my frequency distribution. But now we're not only going to organize it, but we're going to graph it. We're going to be able to present this to people and manipulate their minds. God, we hope not, but you never can tell. The first of the graphs, and probably the most important because it comes directly from the frequency distribution, is called a histogram. It's this guy over here on the left. These are examples of histograms. They look like bar graphs, but they're not. They're a very specific type of bar graph because the histogram comes directly from the frequency distribution. If you look at this one's a little bit blurry. Sorry about that. What you have here is you have some numerical values, and then up here you have the frequency values. This one's a lot easier to see what's going on. Again, this is our quiz. So if we were to look at, so let's say that I gave a quiz to, let's see how many people we took this test. All right. Well, let's get our brain wrapped around this first. What are we looking at? We're looking at quiz scores. These are scores down here. Okay, and then these are the number of people that made that score. Now, we could easily transfer this graph into a frequency distribution if we wanted to. Be really simple. Okay, they just chose to have their class widths be 1, which you can tell by looking at the graph. So look, it looks like one person got at or below a 4. It looks like, which that kind of violates the rules about frequency distributions because they're supposed to all be the same width. We don't know if this person got a 4, a 3, a 2, a 1, or a 0, but for the sake of argument and to be clean, let's say that they got 1. So one person got a 4. Appears as though 2 people got 5s. Looks like 5 people got 6s. Looks like 5 people got 7s as well. Looks like what, 11 people got 8s. 3 people got 9, and how many people got the 10? Looks like a 5 as well. That's kind of useful information because look at it. We can tell how many people took the quiz. Looks like what, n equals 32. Let me double check that though. Let's see. There's 15, 26, 32. Yeah, so 32 people took the quiz just by looking at the histogram. So it's a really useful graph to be able to pull stuff out of. All right, now I'm going to show you real kind of down and dirty, quick and easy how to make a histogram. It's not going to be the prettiest thing in the world because I don't have the ability on this tablet to make things beautiful, but there are lots of other ways. I'm going to show you with your calculator how to do them as well. Okay, so we're going to take our frequency distribution and we're going to turn it into a histogram, and it's pretty simple to do. Well, let me show you a couple of tricks. All right, first things first. I'm going to put my frequencies here. And I'm going to put, whoa, down here, sorry. I'm going to put, wow, that's terrible. I told you I wasn't great with this thing. There's got to be a little app where I can have it draw as straight as I want. You'd think as a mathematician I'd be better drawing straight lines. Okay, first things first, I'm going to put a 123 or 113.5 here. Now there's a little trick in statistics, or excuse me, in graphs, and sometimes you'll see it on a graph. You'll see this little, almost like a little tilde there. It means that scale is not preserved. So in other words, the distance from here to here is not 113.5. All right, so we'll put 113.5, 123.5. It appears as though I went over what, 1, 2, 3, 1, 2. I am going to try and preserve scale. This is 133. That's just terrible. I'm having a heck of a time with my tablet today. Sorry, guys. This is 133.5, 3, 143.5. Again, down at 30. 153.5, 1, 3, 163.5, and then over here to 173.5. Okay? And then all I'm going to do, if you recall, let's make this, what was my biggest value? If I cruise over here, I think it was an 8, wasn't it? Yeah, my biggest was an 8. I started at 2. Okay, so I got to go, let's see, how far up do I have to do? I'm going to go, oops, I'm going to go, well, let's make it 2. Let's make it 4. Let's make it 6. Let's make it 8. If I wanted, I suppose I could count all the way up, but you'll get the point. All right, so now all I do is I use my frequency distribution, I'm going to build this sucker out real quick. I've got 2, 3, 5, 8, 6, 4. Let's see if I can remember that. See if the old brain's working. So for the weights between 113.5 and 123.5, it was 2. So I just build this guy up right here. For the weights between 123 and 133.5, it was 3. Now my pen may act a little funny here. That it was 5. So I'm going to do that guy right there. 2, 3, 5, and then it was 8, wasn't it? So 8. There's that guy right there. And then there was 6. And then there was 4. I guess it is kind of filling those in. Look at that. Isn't that pretty? Let's double check just to make sure I'm not crazy. Let's see. 2, 3, 5, 8, 6, 4. Perfect. And that is our histogram. And if we wanted to, we could get all kinds of fancy schmancy with it. We got weights here. All right. You could color it in, you could fancy it up, but look at this. Look at how much easier it is to really start to get an idea for what. Remember that NV DOT? NV, I just did Nevada Department of Transportation. Remember CV? Sorry, you're a little punchy. CBDOT. I can, but just by looking at that histogram, I can figure out where the center is. I know what the variation is. I know what the distribution looks like. I can determine whether or not there are outliers. And for that problem, we don't really need to concern ourselves with time. So if I look at this bad boy, center's going to live, I don't know, somewhere around here, right? The variation, somewhere between 113.5 and 173.5. What else do we have there? We've got the distribution. Well, it's sitting right in front of us. Doesn't appear to be any outliers. There's not any crazy values, you know, way up here that are just sitting all by themselves. And then time we don't have to worry about. One last thing that I want you to notice about the histogram is notice that the bars bump up against each other at that 0.5. Remember how we split that difference. It's impossible for a data value to be in both sets at the same time, but protocol says, convention says, really, we just have to run these guys right up against each other. Okay, so that's a histogram.